So a complex number is z equals to x plus iy. That is the form, the basic form of a complex number. Now we can also express it as the modulus argument form, which comes in handy, which is r, which means modulus of z, cos theta plus I sine theta. That is the basic form. This particular form can also be expressed as r e to the power I theta, where r is the modulus of z and theta is the argument of z, like this. R equals to modulus of z and theta equals to argument of z. Now we have a special rule known as de Moivres theorem, and it states that de Moivres theorem. De Moivres theorem states that if you have a complex number z equals to r cos theta plus I sine theta, then you can write z to the power n as r cos theta plus I sine theta whole to the power n, which turns out to be r to the power n, and cos theta plus I sine theta to the power n, which turns out to be cos n theta plus I sine n theta. So what is happening? The de Moivres theorem is basically dealing with this part. Cos theta plus I sine theta whole to the power n is identical to cos n theta plus I sine n theta, and this is known as de Moivres theorem. So here is an example for which we use de Moivres theorem. Using de Moivres theorem, that cos theta plus I sine theta to the power n is identical to cos n theta plus I sine n theta, express cos 3 theta as powers of cos theta. So the first thing that you have to do is write down the de Moivres theorem as 3. So we have to write cos theta plus I sine theta to the power 3 is identical to cos 3 theta plus I sine 3 theta. Now the next thing we have to do is we have to break this left hand side, cos theta plus I sine theta to the power 3. If we did not have the de Moivres theorem, we would have to break this down using binomial theorem. Now the binomial theorem states that if you have a plus b to the power n, it is equivalent to a to the power n plus nc1, a to the power n minus 1, b to the power 1 plus nc2, a to the power n minus 2, b to the power 2 plus nc3, a to the power n minus 3, b to the power 3 plus nc4, a to the power n minus 4, b to the power 4, and on and on. And the final term would be b to the power n. So if we break this down, it would be a is cos theta. So cos theta whole to the power 3 plus 3c1 cos theta to the power 3 minus 1 2 and I sine theta to the power 1 plus 3c2 cos theta to the power 1 I sine theta to the power 2 plus the final term would be I sine theta to the power 3. So we can write this as cos cubed theta plus 3c1. If we use the calculator, it would be 3. Cos squared theta I sine theta plus 3c2. If you use the calculator, that is also 3. So this would be cos theta, and this would be I squared sine squared theta plus this term would be I cubed sine cubed theta. So we have cos cubed theta plus, now this is I, this is 3. So 3I cos squared theta sine theta. Now I squared is minus 1 because I is square root of minus 1. So this is going to be minus 1 into 3 is minus 3 cos theta sine squared theta plus I cubed is I times I squared. So this is a concept from F1. So I times I squared means I times minus 1. So this would be I times minus 1 and this would be sine cubed. So the idea is to write all the I together and all the real part together. So the real part would be terms without I, cos cubed theta minus 3 cos theta sine squared theta. And if you take the I common, it would be 3 cos squared theta sine theta, and this is minus I, so minus sine cubed theta, and this would be I. So now for expressing cos 3 theta, we have to compare the real portion of the complex number, not the imaginary portion which has I. So comparing the real portion, cos 3 theta equals to this. So we can write comparing real. So cos 3 theta is equals to cos cubed theta minus 3 cos theta. Now sine squared theta, we have to express the whole thing in terms of only cos. So we can write sine squared theta as 1 minus cos squared theta. So we can write cos cubed theta minus cos theta into 1 is 3 cos theta minus minus plus cos theta into cos squared theta is cos cubed theta. We can write it as 4 cos cubed theta minus 3 cos theta.